I want to talk now about inclined surfaces, inclines as I call them. So let's put a block on a surface, and sometimes it might have friction and sometimes it won't. I'm going to start with a couple free body diagrams. So let's say this is friction, and let's say this is frictionless. Both boxes will have a gravitational force down. Both boxes will have a normal force. The normal force is perpendicular to the surface. If there's friction, the box is going to want to slide down the plane, the surface, so friction should go up in that direction. If there's no friction, it will slide down and there will be nothing to slow it down. If you have friction, hey, it could be, depending on the amount of friction you have, it could be enough to slow it down. It could be too little to slow it down and it could speed up, just not as fast as a frictionless box. Either way. But what we do find is that in order to figure out what the normal force is and to figure out what the net force is, we need to look at components to weight. And I'm not going to get too much into how this works out mathematically, except to say that this angle there is the same as this angle there. And you can prove that to yourself. So you can create two components. There is a component of the weight. So the weight itself goes down, but you have two components. F sub g down. And if you look at this in terms of geometry of this, or trigonometry, I guess, if that is your hypotenuse, then this side right here is going to be the opposite side. So it's really just going to be your weight times sine of the angle. And this side here, which is, I'm going to put a little perpendicular sign, because it's perpendicular surface, is equal and opposite to your normal force, is going to be your weight times cosine of theta. It's not on the reference table. There is a chance that you might actually have to calculate this at some point. So you should know how to do it. You're more likely to have to figure out what it is down the incline. So F sub g sine theta, right? Your weight times theta. If you don't know what your weight is, it's just mg times the sine of the angle. So let's say that you're sliding down and you're moving at a constant speed, which would be like this, right? And you might ask yourself, what's the force of friction? Well, if it's the same block, we know what the force of friction is because it's got a balance, right? Here, there's nothing to slow it down, so this component takes it down. But as soon as you add friction, that component down has got to be equal and opposite to the force of friction. So in this case, it's opposite to F sub g times the sine of your angle theta. So if I made up numbers like I said, oh, it's a 2 kilogram box, and I said the angle was 30 degrees, I could say, well, let's see, force of friction is your weight, which is 2 kilograms times 9.8 meters per second squared times the sine of 30, which should end up being, sine of 30 is 1/2, 2 times 1/2 is 1, 9.8 newtons. So, terrible me, I came up with an answer that's 9.8, right? What a total coincidence, because I tell you not to use 9.8 too often, but in this case, the math actually turned out that way. Inclines can be definitely tricky for people because you're looking at sines and cosines and angles in slightly different ways than you are used to looking at them. One last thing to keep in mind, if you get confused and you cannot remember whether you should deal with sine or cosine, think about it this way, right? 30 degrees is a kind of small angle. You should have a lot less force going down than you would if it was a 60-degree angle. So in a 60-degree angle, you're going to have more force pulling you down the incline. So if you can't remember whether it's cosine or sine that pulls you down, just think about it this way. Sine of 30 is 1/2. Cosine of 30 is 0.87. So there's a small angle, so you shouldn't have as much force pulling you down the incline, so it should end up being the sine, which is the smaller of the two numbers. So I hope this helps. Thank you very much for watching.